So now we'll be starting today's webinar with a brief introduction of the invited speaker. Professor Dr. Swagatam Das earned his ME and Ph.D. from Jadavpur University. Currently, he is a professor at the Indian Statistical Institute, Kolkata, and he previously served as the head of the Electronics and Communication Sciences Unit at ISI Kolkata. Presently, he also holds the position of Professor and Deputy Director at the Institute of Advanced Intelligence, TCG CREST, Kolkata. His research interests include deep learning and non-convex optimization. He has published over 400 research articles in peer-reviewed journals and international conferences. Dr. Das is a founding co-editor-in-chief of SWAM and Evolutionary Computation. He has served as the associate editor for several prominent journals, including the IEEE Transactions on Learning System, IEEE Transactions on Cybernetics, IEEE Transactions on Evolutionary Computing, Pattern Recognition, Neurocomputing, Information Sciences, and others. He is a member of the editor board of Information Fusion, Progress in Artificial Intelligence, Applied Soft Computing, Engineering Applications of Artificial Intelligence, and many such prominent research groups. Dr. Das has received over 31,000 Google citation scores and H index of 83 till date. He has actively participated in the program committees and organized committees of renowned international conferences such as NeurIPS, AAAI, ACM Multimedia, IEEE CEC, GECCO, and more. Now, we'd like to request Professor Dr. Swagatam Das to enlighten us with the insights and the expert insight on the topic of large language models. Now it's up to you, sir.
Okay, thank you very much, Shandipan, for extending this invitation. I will be starting to share my screen. If at any point of time you cannot hear me very clearly or the slides are not moving, kindly let me know. Let me just try to share. And I'm not in a very peaceful environment, so occasional noises will continue to creep into the lecture. But anyway, let me share the full screen first. Yeah, I think. So are you being able to see the slide now?
Yes, sir.
Okay. So in next 1 hour or so, let us navigate the hugely happening landscape of generative artificial intelligence in context to large language models. And also I would like to talk about their bias, inherent dangers hidden inside the fairness issues of such models, besides their transformative role in scientific research and exploration. So, but before that, I am assuming most of the audience to have only very basic knowledge about machine learning. So I will try to develop these ideas from scratch and give you a consolidated 360-degree view of this area. Obviously, the area is changing very, very rapidly, as all of us know. So we know machine learning, which has now entered into our tea parties, into our drawing rooms, into all our discussions, because it opens up huge avenues for earning revenue and creating new jobs all over the world, new type of expertise. Naturally, many new gateways are being opened. That's why people are talking about it, and all the leading companies are investing. So any learning system, as we know, it's a system which can take appropriate future decision based on past experience, and more experience flowing in, the capability of taking such future decision enhances. Traditional machine learning, in which some objects will be put before the machine and the machine will decide about their categories. Okay, this is the picture of a cat, that is the picture of a hippopotamus, and so on. In traditional machine learning workflow, which is figure A here, as you can see, the input objects are first abstractly represented to a computer by extracting the most informative, distinctive, and distinguishing characteristic traits or features. Okay, so this representation of an object in terms of the most optimal set of features has been done in traditional machine learning by using human intervened feature engineering. So there are different scientific communities and groups which will do handcrafted methodologies, which will exercise handcrafted methods to extract the most informative features from the input. Once such abstract and higher level features are decided, higher level means which is more close to human interpretation, and lower level means which is more close to machine. Like the pixels of an image are lower level features, but if it's an image of human face, then whether the person has nice French cut or nice pair of glasses, that is higher level feature. Okay, so these features used to be handcrafted, used to be extracted in a handcrafted manner, in a human intervened manner, and the classifier would, then there is some system called classifier which based on these features would decide the class of the object. Deep neural networks, when they became very prominent, mostly from 2012, what they did, their biggest, most important selling point was they integrated this feature extraction with classification through an end-to-end system. End-to-end system means the final cost function at the output, at the final output, the same gradients of the same cost function would guide not only the classifier, but also the representation learner, the feature extractor, which would automatically combine the lowest level features, like the pixel level features I just said, through different linear and nonlinear combinations to yield higher level features. So put it very simply, I might sound too technical, I should not. In normal machine learning, there are human beings, human researchers who would decide what are the most abstract, higher level, informative, distinctive features that should optimally represent maybe a piece of text or maybe a video or an image or a speech signal to a computer. In deep neural networks, the neural network, in almost an automated manner, learns the most optimal representation of a physical object or a piece of data in terms of most optimal features. Okay, and not only it learns the most optimal representation, it learns the context-aware representation. When I go to a bank and ask for a loan, the bank, I become a piece of data in the bank's customer database. Bank starts specifying me in terms of my credit rating, civil score, fixed deposit amount, etc. So these numbers become my feature. Based on that, the manager will classify me into loan approved or loan rejected. Okay. Similarly, but you see, if I change the context, same person, if I now go to a blood bank for becoming a potential blood donor, the blood bank starts specifying me in terms of whether I had thalassemia, what is my age, how much blood glucose do I have, and so on. So you change the context, the most important, most distinctive features that specify you also change. Deep neural networks are supposed to capture the context-aware feature representation. That is the biggest selling point. And these neural networks could be generalized for various kinds of data. So gone are the days when each data item is represented by a vector of some number sitting together, like the iris flower data, which you may all be aware of. Every flower is represented by only 4 measurements: sepal length, petal width, petal width. Gone are these nice days where the data used to be very simple. Our life used to be very simple. Now every data item is literally a Facebook profile, which could have speech, text, image. It's always a multimodal integration of or fusion of different modalities, different types of representation. Like text is one, you are the same person. Your opinions could be represented in terms of text, in terms of short speech, video clips, images that you may draw or you may share. So all these represent you. And these multimodalities give rise to very complicated data items. For handling them, we have different types of network structures like fully connected network, convolutional network, recurrent neural network, etc. Convolutional neural networks are mostly, dedicated to handle this 2-dimensional data, and recurrent nets are dedicated for handling sequential data. So different types of complex data, which could be represented as a vector or matrix or sequence of vectors like speech, video, and of course text, where we are going, can be fed into this multi-layer deep network, and the deep network can also process them and produce similar type of outputs, which could mathematically be a scalar, vector, tensor, or matrix, or something like that. Now, every deep neural network mathematically could be seen as a heavily parameterized function y equal to f of x. And this f of x, this function, unlike the normal, very strict mathematical functions, this function is very flexible. What will be the value of fx for the same x that is not decided by the function alone, but that is decided by several parameters inside the function, which are like the weights and biases of the neural network, which we call as the trainable parameters. And you can make the function behave as you wish it to behave by tuning these parameters. This process is called training of the neural network, and for that tuning, you would require example input-output pairs. Okay, if this is my input, what example output do I want? You will require lots of such example XY pairs, which has been shown below, where the Y, the output, should be first specified by the human expert. This is called training data, and once the training data is fed, the neural network is actually guided through this process. Okay, the human user wants this sort of output for this sort of input. So for the future similar inputs, I should process them in the similar way. That's what the neural network learns through gradual adaptation of its parameters. Okay. Now, coming to the deep learning era, there are two deep inference models which are very popular these days. By the way, am I clearly audible to all of you?
Yes, sir, you are audible.
Okay, fantastic. So one is called the discriminative or predictive deep learning model, where the main objective is the machine will be shown several types of, several pieces of data, and the machine will predict their respective categories. Like in a medical diagnostic system, the machine will be shown of lung, chest X-ray images, and the machine will try to detect small nodules in these images. If it can find the nodule, it will associate a high cancer risk with the image. It will classify it potentially malignant class into potentially malignant class. If it doesn't find such nodules, it will put it into benign class. So two class. Similarly, the data item could be a bank transaction, which is converted into some kind of vector. And by looking at these vectors, the machine should classify it into a benign transaction, into a genuine transaction, or a fraudulent transaction. So these are all examples of discriminative deep inference or simple machine learning inference, where the machine is very happy to learn a decision boundary or a Lakshman Rekha, this sort of a boundary between the classes. On left part of the boundary, it's cat. On right part of the boundary, it's dog. So the machine is trying to put such barriers among different classes of objects when the data is visualized in some abstract feature space. So these circles are basically each of these images. On the other hand, the most happening area, as I just began in the beginning said, of generative modeling. In generative modeling, the machine is more interested, the algorithms are all dedicated to understand or closely approximate the underlying but unknown, which is not fully known, probability distribution of the set of objects. Okay, so we assume when we represent any object as a point in some multidimensional space, like every iris flower becomes a point in a 4-dimensional hyperspace. Any container of gas fitted with a piston becomes a point in the pressure, volume, temperature space. So you see, data items become geometrical objects in some space. They could also become graph or other complicated manifold structures, but I'm not going into that representation history. But the idea is, when data items are modeled as such points in some multidimensional space, we assume they are sampled from some underlying probability distribution. Actually, every data instance or data item, every flower, iris flower, let's say, or every picture of some specific category, picture of all dogs, they follow. This is an assumption of Riemann manifold statistics, that all these images follow an underlying probability distribution. They are all samples from a stochastic process, which is governed by some rules of probability. So in generative modeling, this probability distribution function is approximated as closely as possible by using a neural network interface or a neural network system. This is an age-old problem in statistics. People give, 10 scalar numbers are given, and you need to tell me the Gaussian distribution from which these 10 numbers are most likely to have been sampled. So people attack this problem with, maximum likelihood estimation or maximum a posteriori estimation. But instead of 10 scalar numbers, if I give you 70,000 images and each image is 100 by 100, 100 pixel by 100 pixel, then you are dealing with extremely high dimensional objects. The lowest level feature dimension is 10,000 because each image has 10,000 pixels. And then your job is to, estimate this 10,000 dimensional probability distribution from where these images might have been sampled. If you can even approximately estimate this distribution, then in the next step, you can sample from that distribution. That means you can create artificial images, and nowadays artificial text, artificial video, artificial whatnot, which will just appear very, very realistic. And it would be very difficult to tell them apart from the real world image, text, etc., which are obviously created by some human user versus these artificial artifacts which are created by AI or generative machine learning. So the generative modeling, the fundamental goal of generative modeling is to create or synthesize artificial data objects. And the story I just narrated is the statistics behind it. They try to estimate a probability distribution. They try to get closer into the probability density function if it's continuous. And then they try to sample from that probability density function. That's the goal. So I will skip some of this. So coming to this indirect training process, sometimes the idea is the neural network will take an extremely easy probability distribution function at its input, like this single pick Gaussian, and the neural network will try to convert it into or try to deform it in the shape of a multimodal distribution like this bimodal Gaussian. Okay. There comes the generative adversarial network. Many of you are aware of it. Shondipon is an expert of it, I know, and many of you might be working. So in this GAN or generative adversarial network, we have two neural networks. The idea is very simple. Every neural network is like a function. You can see all neural networks as a highly parameterized mathematical function. That's it. So the generator is a function which accepts a 100-dimensional or 50-dimensional vector, noise vector. That means its entries are all stochastic from some easy distribution and converts it into an image, artificial image. Initially, those images are very, very poor, like this one that you can see here. On the other hand, the discriminator takes an image at its input and assigns a continuous score between 0 and 1 to that image based on how realistic the image looks like. The discriminator has access to the external set of example images. You need to show this sort of networks lots of example images, only then they can synthesize. So the discriminator assigns a score. Based, if the image is very realistic, the discriminator will assign a score close to 1, otherwise it will assign a score close to 0. And based on that score, the generator, initially the generator, which is like an untrained kid who tries to draw, some zigzag patterns on a sheet of paper. So this kid initially doesn't have any training in painting, so he or she will generate some random patterns. And the teacher will assign very low credit for that, and the teacher will try to guide the kid. Similarly, the discriminator, like a teacher, gives feedback to the images coming from the generator, and based on that feedback, the generator tries to improve its images in next iterations. This way, the discriminator improves, the generator improves, and then the generators improved generated artificial images are also used to train further the discriminator so that it could, it could understand the subtle levels of distinction between such improved images and the real world images, and the discriminator is also updated. This way, both of these neural networks, we say they compete with each other. They are in a tug of war situation, and in game theoretic language, they play a two-player zero-sum game and improve each other. This is just one example where you can see GAN in action. So it starts from completely random set of black pixels and arranges them to form this sort of artificial handwritten digits. This is just the first 50 epochs. So do you see generative modeling in a sense tries to create meaningful data starting from noise? Okay. So if you look at the initial pictures near zero epoch, it's full noise now. And then these pixels are gradually being arranged to form this sort of, digits. And this is how the GAN images evolved with time. They are taken from the Progressive GAN project. And if you look at the image, this lady in 2018, or this handsome young actor from 2017, if you look at, before that we didn't have NVIDIA GPUs and so on. So if you look at the lady, you can see the wrinkles around her eyes, her gray hairs and so on, but the lady doesn't exist. So this is a photorealistic image of some person, some ghost person who doesn't exist in reality. Then the generative model went through, the GANs went through a huge lot of modifications. Along with GANs, there is another nice family of generative models called variational autoencoders, which has now become very contextual in the era of diffusion models. GANs went through a huge set of changes, like the conditional generative CGAN came into picture, where you can restrict the generation process by imposing certain conditions. You can say, okay, you need to generate human face images with goggles and eyes and so on. So this way, only goggles, or human face images with only French cut. This way, you can use some ground truth for converting an image into the nighttime image, or daytime, winter landscape into summer landscape, and so on. Close to that, you can also increase, the low resolution image into higher resolution image just in a handheld device by using super resolution GAN or similar structures. This is a clip from the famous Interstellar movie. You can do image-to-image translation, which has now been adopted for a long time, 3-4 years. It has been adopted for voice conversion, also for text style mixing also, and also for cross-domain translation. So here you see this particular system of two GANs acting in parallel translates the visual style of one image into the other image, the content of the other image remaining same. So horses are being converted into zebras and vice versa, or you can mix the two games. This sort of works were very popular in the realm of visual effect, image-to-image translation. For example, we had a capsule network with this spatial optimal transport induced loss for source to target translation. So you see, this is the input image. This is from one of our papers. And these are the different, seed images or so target images. And what if the same expression is translated into the faces of these ladies, or the expression of this person is translated into these? So not only among humans. So you see, this particular expression of the cat is now being translated very implicitly into dogs. And this is just a continuous view of the same thing. So you see how Dev Patel, his face changes with these expressions, or these source images from where the translation comes. So where it could be very interesting, if one of the classes suffer from scarcity of data, then the GAN or similar architectures could be very interesting, where you could generate artificially synthesized complex data items like images, text, video to populate that class, and to make your data less biased towards the bigger class or majority class. Minority class detection is a very big problem, and this is our work done by my two former PhD scholars, Shankhu Subramullik and Shaunak, in ICCB 2019, where we are showing that we are using a 3-player GAN architecture involving a convex generator, a classifier, and a discriminator for generating this sort of minority class samples and populating the minority class in a nice uniform manner, so that the decision boundary, basically this orange and the green portions are bounded by this line. This line is the decision boundary. The decision boundary should be proper and should save us from a lot of misclassification. Coming to deep generative models evolution, you can see it started with mainly VAE and GAN, then there came flow-based models, and now this field is dominated by diffusion models, which gradually add Gaussian noise into images until the image becomes completely blurred out or completely noisy. Then it starts removing the noise stepwise to recover some other very varied image during the testing procedure, some other image which is a variation of the original one. See, generative models must not synthesize a carbon copy of the training image. That's the idea. Now, the deep generative models are mainly being used to generate synthetic data. This synthetic data, this artificial data, could be used to avoid class imbalance problems. As I said, for cross-domain translation, one image into another image, a textual description into an image into a textual description, which is done in caption generating, changing the resolution of an image, generating more pixels in the same space so the image looks, detailed, speech and music synthesis, computer graphics. These are the best examples known till 2021, 22. And then the rest of the world was taken by storm with the advent of large language models. And large language models, what are these? These are artificial entities which could interact with a human being as if it knows the semantic rules and grammars of a specific language, which is most often English. But hey, computers cannot understand language organically like we do. When I hear red chicken curry, so some images are formed in my head, some sensation, some taste buds, my taste buds become stimulated. Or when you hear KFC chicken wings, something like that can happen to you. So every word gives rise to sensations to our sensory organs. They stimulate our sensory organs in different ways, unless it's a very, very dull word, especially these exciting foods and so on. But computers do not have sensory organs. So how do they understand the semantic meaning of each word? They understand that by looking at the periphery of the word. Okay, so there comes the linguist John Furth's 1957 quote, who says, "You shall know a word by the company that it keeps." So, for example, red. What is meant by red? Red, we can close our eyes and see a color. We can see it in our mind. Okay, red means this color. Computers, they will see what are the other words that are sitting with red very frequently. Red fire truck, red book, red idea, red riding hood. What are the words that are sitting with the word red? Red flower, so on. From that association, it will somehow form the conception of this word red in its huge storage space. So large language models, they are basically a subset of deep learning, and they also has huge, intersection with deep generative models. So they form one very important pillar of generative AI these days. So we have huge umbrella of AI. Under AI, we have learning-based AI or machine learning. Under that, there is a subset called deep learning, which is now, of course, the most predominant subset. Under deep learning, we have large language models, which has huge intersection with generative AI. But LLMs are not just a subset of generative AI. I will tell you why. So, and also this journey from 2012 to 2024, that means current date, testifies the evolution of artificial intelligence towards artificial general intelligence. I say AI to AGI. What is that? When we begin, I told you, when the computer programs were reality, 1980s, 1990s. So in the traditional programming, there is a human expert who will quote some rules, who will create these rules. Like if it has 4 legs, 2 ears, it has fur, it likes yearning catnip, then it's a cat. Okay, fine. Then there came the wave of neural networks in 2012. And not 2012, but around that time. And people started to show 1,000 cat images and 1,000 dog images to a neural network, and the neural network would then learn, okay, if these are the essential features, then it is a cat, otherwise it is not a cat. Based on which hidden representative features the neural network, like a CNN, is inferring that is the research agenda of people working in explainable AI. They try to figure out such portions of the image based on which these decisions are taken. But you have to show it 1,000 cat images and 1,000 dog images, maybe more. And then you will take a new cat image before the network and tell what is this? Then it will say, okay, it's a cat. Then there came, since 2018-19, that time, and now it's at its climax, there came the generative language models, Lambda, Palm, GPT, etc. This is more like, as a very motivational teacher, you will put your student to a huge library. And instead of spoon feeding the student all these images and saying, look, this is a cat, this is another cat, this is even a different cat, and so on, you will ask your student, go to this library, take up any book you want, and learn about different taxonomy of the animal world, learn about mammals, learn about chordata, learn about reptiles, and so on. So go read this huge pile of books. So the machine, the LLM models, they are actually trained over almost entire internet, the entire PubMed, literature repository, web, Wikipedia, all these form their training set. That is why most of the underlying system of an LLM, which we call a foundation model, is actually under the control of huge companies, which are backed up by big investors, okay, like Elon Musk, because they have the computing power through their huge investment, which could train such big neural network-based machine learning systems on almost the entire internet. So let me come back to AGI first. So AGI means now you put your machine, you train your machine with the huge repository of knowledge. It has learned about cats and millions of other concepts. And then you ask it, what is a cat, or what is a dog, or what is a rat? It can give you very nice, complete answer. So general intelligence means it's not very narrow. It's not just channelized on 2 or 3 categories. It has a general awareness of all types of animals, and it can give you nice contextual answers. And that means your scope of asking is also enhances. So what are large language models? I think my prelude has become a little extended. Sorry for that. So large language models are large general purpose language that could be pre-trained and fine-tuned for specific purposes. As I said, they are artificial entities which will pretend and interact with you in a manner that it really understands the semantics of a language, and it can, provide meaningful replies to your queries or work for your specific purposes through 2 very important mechanisms, which are pre-training and fine-tuning. What do they mean? let's try to understand that. Suppose you are trying to train a dog. You have bought a nice puppy dog and you are trying to train it to become, to learn basic postures like, okay, sit, come, down, stay. If the dog can learn all these basic postures, it becomes a nice canine citizen. It will be a grace to your house. Your guests will come, then it can handshake with the guests, it can greet the guests by standing on its two rear legs and so on. But so up to this it's fine. Any good home pet dog will do this. But if you wish your dog to act like a special service dog, like a police dog, a sniffer dog, a guide dog, or a hunting dog, then on top of this, you will have to give the dog very specialized training. Okay, this very specialized training may not require a lot of time. And if the dog is really very, very sensitive, it can very quickly catch up that and serve one of the specific purposes. Similarly, large language models are neural network systems of course, very large scale. First, which are used to solve very common natural language processing tasks like text classification, question answering. Some lines of text are coming and you can ask if this text is expressing a negative emotion or a positive emotion or a neutral sentence. Sometimes we call it, sentiment analysis. So text classification, question answering, some paragraph is fed into the machine and you ask some questions. It's like comprehension test. Document summarization, rephrasing, paraphrasing. Then there comes text generation, question answering like chatbots. So all these common NLP tasks are first, they are trained. These models are trained with this. And then the model could be tailored for very specific tasks like stock market prediction, okay, financial trend, okay, financial security enhancement, entertainment, generation of specific music or generation of small lyrics lines for a specific song. All this could be done with a relatively small size of domain specific data sets and with relatively small amount of training. That means you have a generally intelligent, proficient, natural language processing neural network system. We usually terminologically call it the foundation model. It's a versatile model which should be proficient in multiple NLP tasks. Then you adapt it for solving your specific problem. Like maybe you can adapt this system to go through the recent tweets about some big company. Let's say the tweets are happening on Saturday. Monday, when the share market opens up at 10:30 a.m., if the trigger point arrives, what would be the share price of this company? It may happen that in Friday, Friday afternoon, some very bad thing has emerged about the company. In the social media, everyone is talking, oh, this company is horrible. It has done this much misdeeds and so on. Based on these tweets, can an LLM predict the stock situation of the company for Monday? That is retail. Several such applications are there. And now a big chunk of business, especially the startups in India, there are 150 plus startups just, gearing up over 2022 and 23. All of them actually survive on the basis of such domain-specific adaptation of large language models which are already there from OpenAI and other big giants like Google. So again, what are these large language models? They are deep neural network models with huge number of trainable parameters. They are usually initially trained for common NLP tasks in large volumes of text. Okay? Large volume means the entire Wikipedia, the entire PubMed, and so on. LLMs, they started to emerge around 2018, and then as they become more and more proficient, as also more and more popular, the number of parameters and their capabilities enhanced. this is a necessary evil. If you wish an LLM to work very nicely, its number of trainable parameters will become like, you see, GPT-4 has over 100 trillion parameters. So some popular LLM examples are like GPT series 3, 3.5, 4 from OpenAI. Similarly, Megatron tuning NLG, Palm 2, Lambda, Bard, these are from Google AI, Llama from Meta, Wu-Dao 2 from Beijing Academy of Artificial Intelligence. In China, everything is under government's control. And then you can, for example, this is a screenshot from MedPalm 2. You see, you upload a chest X-ray image, and MedPalm 2 is specifically tailored version of Palm 2 for, you know, for analyzing such medical images and providing you diagnostics, findings, key impressions, and so on, more like an original pathological medical test report. So MedPalm 2 can generate such reports by looking at the image. So this is what large language models have been doing. And at the heart of LLMs, there is this specific neural network architecture, which is called transformer. Transformer involves two neural network blocks, which have stacked architecture inside. One is the encoder. The encoder accepts input text sentences, which are sequence of words. And sequence means the ordering of the words do matter. In a normal classification problem, the order in which the iris flowers are being fed into the machine doesn't matter. But in text, you cannot change the order of words, right? The meaning will change. So you have a transformer. The encoder block accepts a textual line or sentence, multiple such lines, and they try to represent these text sentences, the words specifically, into some very mysterious abstract space. We call it the latent embedding space, in terms of floating point vectors, which are called encoded vectors. So the line of text, the words, which are strings, character strings, these character strings are converted into floating point vectors, which these vectors have some meaning, which is still not very clear to the machine learning group scientists. So these vectors, floating point vector means the lines of text are actually transgressing into some points in some higher dimensional mathematical space. This space is called latent space. And intuitively, when suppose you are using this system for a neural machine translation, so the same word, ma, amma, mother, okay, all the thai, so all these words, ma, amma, thai, mother, all these words in different languages should actually go to the same space of that mysterious latent space where these encoded vectors are there. Then there is another block called decoder. The decoder actually samples such points from this mysterious space where these sentences and words are being kept by the encoder. The decoder samples from there and converts these floating point vectors back into text, maybe a textual line in some other sequence. So you see, this is a line in one language, and this is the output in English. And while doing that, transformers, the precursors of transformers were the recurrent neural networks, large long short-term memory, gated recurrent unit, bidirectional LSTM, many sequential models were there. But their scope, their window, the sequence is over time. So if there is a large body of text coming in, usually LSTMs or GRUs cannot handle very large volume of text, cannot associate the current word with other words associated with the large previous volumes of text. On the other hand, when you are talking about generating text, all of you are familiar with ChatGPT and other large language models, which you might have worked in your lifetime. You have seen they are putting next words and generating a line of text. Every large language model has a huge vocabulary. From that vocabulary, it has a lot of words. So the large language model, based on what text it has generated so far, what text has been fed to it, very roughly, based on that, it assigns a probability to each of the words in its vocabulary and picks up the highest probable word as its next word. Once that next word is put, it can again take up the next word from the vocabulary. This way, in an almost autoregressive manner, the decoder part of the transformer generates text. But first, it assigns probabilities to these output vocabulary words through a softmax mechanism. And it is backed up by a mechanism called self-attention. So you see this paper from NeurIPS, at the time it was NIPS 2017, the title of which is Attention is All You Need. Everything started with this paper, and machine learnists are very good at giving nice titles. You should read it. What does it say? You see, when as adult people we read a sentence, we don't read each of the words by pronunciation or by spelling the word. We do not read each of the articles, prepositions, conjunctions, etc. Our reading process automatically filters all the unnecessary things and picks up 2 to 3 keywords or maybe 4 keywords from the sentence, based on which the meaning of the sentence is already formed in our mind. These words are very much associated with what we have so far read. Self-attention mechanism tries to find a kind of correlation between groups of words so far fed or so far generated from a system, like an encoder or a decoder. Both sides we will have attention mechanism. So the attention mechanism can associate the most recent word with all the previous words that have been fed into the encoder or that has been generated by the decoder. Okay, and through such correlation, it can understand which words are very close to each other, which words are forming a specific context because of having higher attention score compared to lower attention score. This is more like you look at a text line, you are reading a novel, maybe a Bengali novel, you look at the text line and the meaning of a particular sentence is formed based on only 3-4 keywords. You are not consciously taking up all the interjections, prepositions, articles, and so on. So this is just showing, as the new words are coming in some other language, how it has association with other words in the previous language sentence. Self-attention mechanism is implemented by using simple dot product and matrix vector product mechanisms. I don't have time to explain this complicated thing here, but I told you at a very meta level what it does. It finds out close association among major keywords in a huge body of text, and it is a part of, this mechanism is a part of both the encoder block and the decoder block of the transformer. There are various types of LLMs, like the zero-shot model, fine-tuned or domain-specific model, only language representation model, which forms with the encoder part of the transformer, like BART, and they just learn the proper representation of the language for further usage. On the other hand, GPTs are mostly, the decoder part of the transformer. The encoder part is not there, contextual, or is not open. So fine-tuned or domain-specific models, they are specifically, tailored for some special purpose, like the GPT-3, which could be fine-tuned for domain-specific purposes, forming, for example, Codex from OpenAI, which is typically a programming tool for LLMs programmed with GPT-3. Then we have the multimodal models, and the entire world is now running after multimodal GPT models, which are not just handling text, but which are handling unstructured and structured data with equal efficiency, which are handling basically images, videos, PDFs, blogs. It can go to blog from the web link, And the best example is GPT-4. I'm sure most of you are not yet using GPT-4 because of the subscription issues, but there may be some good news in 2024. Some part of it should be open. So multimodal vision text models are the future of LLM, not future. Now it is very much developed even in the present context, I can say. So you see GPT-4 visual input examples. If you give this picture, it's a meme basically. Some chicken nuggets are there. So the user says, can you explain this meme? Sometimes I just look at pictures of the earth from space and I marvel at how beautiful it all is. This is a meme. Some chicken nuggets are forming like a world map. Am I still clearly audible to all of you?
Yes, sir.
Yes, sir. Yes, sir.
Very good. So if you ask GPT-4 about this, if you upload this picture and if you ask this question, GPT-4 says this meme is a joke that combines two unrelated things: picture of the earth from space and chicken nuggets. The text of the meme suggests that the image below is a beautiful picture of the earth from space. However, the image is actually chicken nuggets arranged to vaguely resemble a map of the world. See, it tells you what the meme is all about. It completely clarifies the meme. Similarly, DALL-E 3 is text to image generated. DALL-E 3 operates on the principles of stable diffusion model, which is the state of the art in generative AI for computer vision. So if you prompt, you can prompt some lines of text and it can generate some befitting picture matching your prompting. So you can ask, can you design an abstract image of jellyfish in outer space? And it will create this beautiful picture. Now, with the help of advent of DALL-E 3 and upper versions, it has become very easy to create original illustrations for the book you are going to write, or for a greetings card you want to make, or similar occasions. Okay. ChatGPT stands for Chat Generative Pre-trained Transformer. So GPT is Generative Pre-trained Transformer. That is mostly the decoder block. And since its launch in November 30, it is taking the entire world with storms. It is enabling the users to, lead a conversation towards desired length, format, style, level of detail, and of course, its variation in language vocabulary is huge. Successive prompts and replies could be fine-tuned, could be tailor-made through a process called prompt engineering. And this is a prompting from ChatGPT. Describe yourself and what functions or tasks you are designed to perform. It will say, I'm ChatGPT, a product of OpenAI's GPT 3.5 architecture. So please, ChatGPT is not an LLM. ChatGPT is an interface between the GPT 3.5, which is the LLM, and the users. Okay. How does ChatGPT works? It utilizes GPT 3.5 LLM as its underlying model. Okay. Then it incorporates an extra layer, a model called Instruct GPT, which now has become quite a standard within OpenAI language models. Instruct GPT has a human-in-the-loop reinforcement learning mechanism to improve the conversational abilities on top of the existing GPT models. This is very unique. So lots of content filterers all over the world have been working. Now that work has been taken a very nice shape. And not only content filterers employed by OpenAI, you, me, whoever is using ChatGPT, we can provide feedback on the correctness, on the completeness of whatever ChatGPT has shown us against our questions. And based on those feedbacks, through a specific learning mechanism called reinforcement learning with human in the loop, human feedback, we call it RLHF, GPT 3.5 can actually improve its answers when the answers are being leveraged by ChatGPT. So ChatGPT is basically the GPT 3.5 plus this Instruct GPT model, which will be used for fine-tuning and providing the users more correct answers. Until the user is satisfied, the user can regenerate such things. Then there comes prompt engineering. Prompt engineering is by far the most lucrative job in USA, at least it was in 2023. And it refers to crafting effective prompts or instructions to guide the behavior of the language model or an AI system. You have a language model, you want to make it write an answer which befits your purpose. So it can involve formulating queries or commands to elicit the desired response or output from the AI. Prompt engineering is very crucial for fine-tuning models like GPT-3. So you see, I think I will extend by 5-7 minutes because some more parts are remaining. There are some simple examples of prompt engineering, like you can ask the GPT to translate a sentence from English to French. Unclear prompt is simply translate this. On the other hand, a more clearer, effective, complete prompt is please translate the following English sentence into French. How are you today? So you have to give complete instructions. Otherwise, the large language model will not respond to your queries the way you like it. For example, generate a creative story starting with a given sentence. If this is the task, unclear prompt would be, you just write the sentence and then you just give this instruction, continue this story. This is not a very clear prompt. Clear prompt means unambiguous instruction to the LLM, following which it would give you in a very small time the right set of text that you want. So the effective prompt would be build a story around this opening sentence. The old house at the end of the street had always been ... So with the release of the paper, this is a very interesting paper. Large language models are zero-shot learners. They showed how large of an influence prompt prefixes had. So if you have a prompt, the prompt has huge prefixes on the model reasoning performance, the way the model reasons and tries to solve your problem. So a very interesting problem statement. If you precede your problem statement with the phrase, let's think step by step. For example, you give it solving some simple arithmetic problem. On average, Joe throws 25 punches per minute. A fight lasts for 5 rounds of 3 minutes. How many punches did he throw? You type this question and also give it an opening prompt like, let's think step by step. Then the LLM will give you line by line reasoning and solve this problem, give you the final answer. But if you do not do that, it will definitely go to the answer at just one step, which you may not want. So this way, you can provoke the large language models with proper and clear prompting to align its delivery with your thoughts. Yeah, I am not going to extend to this way. Can advanced mathematics help language modeling? Yes. The reason is language could be seen as an algebraic entity. For example, as I said, red, this word is sitting with different other words. This sitting of two words together is much like multiplication. We call it compositionality of the word structure. But at the same time, language is statistical also, because the red will sit with many other words. But which are the words which most frequently sit with red? That will also be responsible for forming the meaning of red. So algebra plus statistics gives rise to some very, very high level and advanced form of mathematical theory that is called category theory. Nowadays, the large language models are being backed up, or their functionalities are being explained in terms of this high-end mathematical structure called category theory, but I'm not going to tell you about this. If you are very interested, you can look at this nice paper for the initial exposition. So I will have to end it gradually. How large language models can be utilized in scientific research? They can be excellent tools for scientific research. They can very effectively summarize large papers or scientific documents. They can summarize even blogs. They can very nicely assist you in data analysis, interpretation, research hypothesis generation. They can rephrase paragraphs of your paper, which are originally written by you. But whether this is a plagiarism or not, big debate is going on in IEEE and Elsevier. They say if you make large language models a collaborator in your writing, if you write papers and you ask large language models to rephrase or write some sentences, you should acknowledge it by referring to the LLM for those sentences. But that is a different debate. Apart from, I mean, of course, it is very bad that a school student writes all its essays with the help of LLM. But LLMs, on the other hand, could be very nice assistant who could give you codes, code examples, who can improve your code. You write some code and the LLM can debug the code, especially in Python, Java, C, all these languages. LLMs could be very nice if their foundation models are rightly trained for, cross-language research collaboration. They can, at least in world-leading languages, they can very nicely translate one language into another. They can assist in experimental design, extracting insights from unstructured data. And as I said, with the help of multimodal LLMs like GPT-4, DALE, they can be very, very interesting in generating nice educational teaching materials and could be a great assistant to young and even senior teachers who want to quickly make nice PowerPoint presentations. Nowadays, nobody makes PowerPoints with no tech-savvy people make PowerPoints with their own hands. There are specific fine-tuned LLMs which are built on GPT 3.5 or 4, GPT-4 multimodals. They can generate nice PPTs for you. And these companies are charging some money. That is business, basically. So creation of educational or teaching material for explaining complex concepts is another idea. This is an example of composing a grant proposal, a project proposal. So you can compose a funding proposal to the Department of Science and Technology, Government of India, outlining research in the field of LLMs and demonstrating its potential utility for the government. So the chat GPT is starting this whole draft, and it can nicely write some space. It can keep some placeholders to be filled up by you, but it can give you an overall framework and nice structure with clear headings, budget breakdown, milestone map, and other things. Expected outcomes, deliverables, alignment with national priorities, and so on. Then once you get this whole write-up, you don't have to do it from scratch. It will save a lot of your time. You can now enter into it and change a lot of aspects, put your own things. Then again, you can have it rephrased in nice, better English by ChatGPT and so on. This is the way it could assist in writing proposals, summarizing a blog, for example. Summarize this blog post, this entire blog post, or even you can chat GPT, which is free to us, cannot do reading from a specific URL, but GPT-4 can do. I don't have to copy the whole thing from the blog here for GPT-4. I can simply give this hyperlink, and then you have a huge line of volume of text, huge blog. ChatGPT can actually summarize it within the word count you provide, and you can read that summary and you immediately know what is there in that big line of text. Coding, as I said, problem solving, concept explanation, language assistance, learning processes, all these code examples it can do. And it can give you, it can break a big problem into small problems like we do in divide and conquer phases. It can convert a Python code into a C code or a C++ code into a Java code very, very easily. These are cakewalk for it. It can explain even newer concepts like what will be the metric for rotating black hole connected by a wormhole. It's an intricate problem from physics, but it can even generate this sort of equations and make you understand. Nowadays, so what is particle swarm optimizer, which is a very specific meta-heuristic swarm intelligence algorithm for solving optimization problems? ChatGPT, not only it can explain this to you, but if you ask it, can you generate a newer version of particle swarm optimization? This is clear prompting. So I am prompting ChatGPT. I wish to write a paper. I am prompting ChatGPT. This is a bad practice. I'm just showing you its capability. I'm asking it, can you formulate a new variant of PSO? Let's call it exponentially averaged momentum PSO, which will stick to PSO's major advantages, such as higher robustness to local minima, providing more weight to exploration part, and so on, and which would do a good trade-off between code search and fine search, etc. ChatGPT can actually make the algorithm for you, and then it can write down the code of the algorithm for you. You can have it tested. This is very, very bad practice. So you can get the results, and if the results are very good, you can publish a paper. So you are doing this research on the shoulders of ChatGPT. Although very often we need to be this is very tempting, but we have to remember ChatGPT is not really until date intelligent being. It's only pretending to be intelligent. So what it gives to you sometimes would be full of misinformation, sometimes would be misguiding, and sometimes will be plagiarized from some other content. So if you want to use ChatGPT in this manner, it could be very helpful, very, very, harmful. We do not know. It has written certain equations of this new PSO model, but this new model might be already somewhere in some other name. Nobody knows. It might have changed the basic, symbols. It might have changed some names. It might have inserted some new words, coined some new words, because I prompted it to create a new version of the algorithm. It doesn't mean it, like a human researcher, it has real research imagination and it has really conceptualized a new type of movement. No, it can only mimic to be intelligent. It is still not really intelligent. Although a lot of semi-fictional stories are hovering in the air about this. Now the question is, are we ethically on the right track? Are we achieving equitable and responsible AI? No. There are a lot of concerns. ChatGPT and similar foundation models, most often this versatile model which forms the base, which forms the foundation of all the LLM interfaces like ChatGPT. These are called foundation models. These models are under the control of people who are in power. That means the investors and the big companies. They have unfathomable training data, but size doesn't guarantee diversity. They have huge encoding bias. And, who are the contributors to Wikipedia? Wikipedia is the training material for ChatGPT. Who contributes to Wikipedia? People from Europe and America mostly. Hardly people from Africa who do not even have a 24-hour power supply, who might have 2-hour power supply per day. Very, very poor. Do they contribute? Do they have the luxury to write articles over internet? No. So what happens is, the net result is a limited set of population in the world continue to easily add data, sharing their thoughts and developing platforms that are inclusive of their worldviews. History, documented history, is the fiction of people who won wars. Documented history doesn't say anything about the people who were defeated. Similarly, people who are in power, their worldviews are being digitized. Their worldviews are coming into these higher end platforms like Wikipedia, PubMed, everywhere, and is becoming the worldview of the rest of the people, is being imposed as the worldview of rest of the people. This is the training data for large language models. So various forms of abusive language, harassment against different groups of people who are, of course, minority, like this LGBTQ community and others. These are going unaddressed, may very often proliferating very harmful content. I will just, so why it is happening? Because the gatekeeping is always done by those who are in power. They are controlling the whole thing. This is an example of gender bias. So you see more examples in ChatGPT. Don't praise Donald Trump. If you write this prompt, create a poem admiring Donald Trump, it will say, I'm sorry, I'm not able to create a poem admiring Donald Trump because Donald Trump is not in power. But if you prompt it, create a poem admiring Joe Biden, it will write a poem. It will say, Joe Biden, leader of the land with a steady hand and heart of a man. So it praises now with a nice poem. And it very often creates racist and sexist programs. Write a Python function to check if somebody would be a good scientist based on a JSON description and of their race and gender. So what it does is, if the race is white and the gender is male, then this person will become a good scientist. This is clearly racist and sexist. Similarly, whether a child's life should be saved or not, if the child's race is white or Asian, gender is female, then save it. Amazon scraps secret AI recruiting tool that shows bias against women. Bias against women is implicitly there in several foundation models, which become more prominent when it goes to downstream tasks. That means the fine-tuned purposes for which it is being used. So if you ask it to write a family story, it will of course say, my mom is a homemaker, my father is a doctor. It will never say, my mom works outside and my father cooks in the home. Similarly, if you use it as a sentiment analyzer, it will say, he loves travel alone, joy. Prediction is joyful. She loves travel alone, it will predict fear. A girl is traveling alone. Why it is doing this? Because the data based on which it is trained is biased. The data comes from society, and the society is biased. So the same problems are persisting in the data and protruding into large language models. So be aware of, do not believe whatever text is being generated, whatever it tells you, do not believe it fully. Read it line by line, intersect it, post-mortem it, and then you can use some part of it. Still, large language models require lot of human intervention and filtering because of these inherent biases, and we do not know how the foundation models are being trained. So I will simply end up now, 4 emerging issues that we need to overcome related to GPTs and AI. Bias in various forms, a measure of such bias, a measure of fairness, lack of explainability. In LLM, explainability is a very big matter which needs further study. Ethical concerns, misinformation. LLMs can provide huge misinformation in various ways. Okay, it can mix up things and so on. So I now hold 2 positions in 2 institutes. I'm on 1-year sabbatical leave. So I wrote, so in my homepage it is written, I am acting as professor of art, Indian Statistical Institute. I am deputy director of IEAI, Institute for Advancing Intelligence under TCG CREST. Now I ask ChatGPT, who is Swagatam Das in 2023-24. So it writes, he is the deputy director of Indian Statistical Institute, which is absolutely false. So it has mixed the 2 things, and he has no idea what it is saying. This sort of misinformation very frequently emerges. You have to be cautious. Miles to go before we sleep. Inclusiveness in training data. Cultural ChatGPT and other LLMs are far away from understanding the cultural idioms in different local languages. Some phrase could be very humble in your language, but very harmful, very disrespecting in my language. When it comes to a multilingual country like India, where there are 25 official language groups, this cross-lingual handshaking procedure needs to be very, very carefully designed. Let the usability of AI tools trickle down to non-computer science practitioners through the large language models. Generative AI platforms must include a detection differentiation mechanism. This from between the artificial content and the real content. Such mechanism should be the precondition for public release of generative AI products. Already there has been some campaigning and other movements to implement to force this as law in US and other countries. No law enforcement should be based on biased ML models. Large language models are hugely computationally intensive. It is beyond our reach to train foundation models. It is within the capacity of only companies like Google, OpenAI, Amazon, and so on. So the fundamental research in artificial intelligence and machine learning should focus on how to reduce carbon emission. Our brain is much more capable than the best supercomputer available these days, but it consumes the power of just a 10-watt bulb. So can we look more into neuroscience to understand and design future neural systems which will not consume so much of power, so much of computing? Finally, how can we build AI technology that decentralizes power, protects our people, especially the marginalized people who are most vulnerable, and offer key benefits to the members of these marginalized communities? So we have to work for the growth and trickling down of AI to all social strata, especially the marginalized ones. With this, I would stop. And if you have any other queries, this is the time when I should answer you.
Thank you, sir, for giving us the insight of the large language model, starting from the deep learning, generative AI, and its recent advancements. So, sir, I have a question. Like if you take the large language models, it is trained with huge data sets, uh, millions of parameters. Now, how mathematics can, to some extent, help us to build instead of large language model, rather low resource language model, which are have similar efficiency, like um, lesser resources it requires and lesser parameters is required. But if it is
Yeah, that is where this category theory based modeling of association, this C, the entire transformer architecture is standing on the shoulder of attention mechanism. Attention mechanism is just a heuristic ad hoc way of capturing association among different words in a big line of text or paragraph of text. Can we, at least for some structured language which is scientific like Sanskrit or English, can we have a mathematical model which could very easily capture such association among different words? This is what the mathematicians now are looking at, and in this endeavor, this category theory based modeling of word association, easy modeling of word association, for which we do not have to execute so many dot products, so many matrix vector operations. These issues are coming. So these are the new age, research agenda. And another, as I said, another, of course, way of making it lower computationally intensive is to look back into neuroscience and see the how the signals are being perturbed from multiple directions. For example, our neuron cells are all surrounded by glia or astrocyte. Till date, the very basic neural network that people use even in transformers are extremely simple. They do not actually include or simulate several aspects of original neurons. If such aspects could be simulated also, even approximately, can that solve the problem of this huge power requirement? So mathematics and neuroscience, from both aspects, these thoughts can converge in next 1-2 years, and we may have some good breakthrough. This is the area. Okay.
thank you, sir. So now we have Kartika. Kartika, you can ask a question.
Hello, sir. So I wanted to know your opinion about like now if we see the research world, most of the ACL or any linguistic conferences, if we see, the majority of like there is a lot of papers on LLMs working and various experiments done with LLMs. And even by from the reviewer perspective, mostly even if people are working on other things, there is this comparison of how the same task LLM is performing on. So what's your opinion on very much LLM oriented research right now?
See, I mean, yeah, the whole NLP community, the irony is even 5 years ago in NLP community was uh, very allergic to such deep neural networks or similar systems. But with the advent of LLMs, they all have turned their focus on this. LLMs, on the other hand, they are not very open to common researchers to do the research. But I believe for next 2-3 years, uh, they are going to dominate. And you see, there are a lot of aspects in which such research can proceed. For example, as we were already discussing, make LLMs faster and cheaper. So when GPT 3.5 first came out in, I think, late November 2022, several people had the concerns about latency and cost of using its production. But the latency and cost analysis has changed rapidly since then. Within half a year, the community found a way of creating a model that came pretty close to GPT 3.5 in terms of, performance, like the Alpasha 7B or Guanaco 7B, etc. Number of parameters reduced from, these two models came in, Alpasha came in March 2023, and the second one, Guanaco, in May 2023. Instead of 175 billion parameters as in GPT 3.5, they took down the amount of parameter to 7 billion. Many other kind of techniques, which are sometimes, coming from common sense or sometimes from core computer science, like this quantization, knowledge distillation, matrix-based methods like low-rank factorization are coming into picture for making LLMs even faster and cheaper. Then there comes designing new model architectures, developing GPU alternatives, which are actually kind of taking us to the twilight zone of software and hardware. But if you are working in pure programming environment, you can reduce and measure hallucinations. Hallucination is a heavily discussed topic. It happens when an AI model makes stuff up. So, as I said, misinformation. For many creative use cases, hallucination could also be a feature. I actually wanted to include it. For most other use cases, hallucination is a bug. So you see, mitigating hallucination and developing metrics to measure the amount of such misinformation or hallucination is a blossoming research topic in LLM. Many startups are working on there, and there are ad hoc ways, there are heuristic ways to reduce hallucination by adding more context to your prompt, chain of thought prompting, self-consistency, and asking your model to be concise in its response. Similarly, optimizing the context length and context construction. Okay. Vast majority of questions that you want to ask to ChatGPT or similar models, they need a context. If, for example, I ask ChatGPT, what's the best Chinese restaurant or what's the best Korean restaurant? The context needed would be where I am asking it, because the best Korean restaurant in Seoul would be very different from best Korean restaurant in New York. So how to automatically optimize or correct the context, how to reduce hallucination, how to make the model much faster, how to incorporate other type of data modalities, okay, like automated unstructured to structured transformation, how it can make a graph given a big paragraph full of numbers and so on. So all these things leads to new research areas. And if you talk about classical NLP, or rigid mathematical sides of NLP. Then there are some good works which are emerging with the application of advanced algebra and category theory to the modeling of language, and such models could be used again as a feedback to improve your neural network. This is the landscape basically. We have to adapt to this.
Thank you.
Thank you, sir. So we have Saurabh Chaudhary and Hima. 5 to 10 minutes. So Saurabh and Hima, you are request to ask a short question.
Good afternoon. Am I audible?
Yes, you are audible.
Sir, actually, I have a question. It's a bit generic, I suppose. Actually, currently, I'm working on summarizing a book, and I have created a data set in which I have asked people to summarize the book, and later on I'll use it to fine tune a LLM model, and then I will try to summarize other books of the same subject using that fine-tuned model. Sir, in this factor, actually, I tried with GPT-3, but the issue, as you were discussing, I had a lot of faced with a lot of hallucinating answers. So, in this regard, and also, sir, fine-tuning GPT-3 is also a bit expensive. So, in this regard,
Yes.
sir, what is your suggestion? Like, how can I make it a bit cheaper and also avoid these hallucinating answers, sir? I've been facing this problem for a long time. I've also discussed with Sandeepan also, sir.
See, I mean, LLMs are very well known to hallucinate facts and make non-factual statements that can undermine the trust. So there are some feedback looping systems like the zero resource black box hallucination detection for self-checking the GPT answers. So what you could do is you could fine-tune, let's say, you can leverage the simple idea that the LLM has knowledge about a given concept and sampled responses likely to be similar and contain consistent fact. For hallucinated facts, the stochastically sampled responses are likely to diverge and contradict from one another. So you can make a small training set, and then you can use GPT-3 to generate some conflicting facts. Okay, manually annotate the factuality of the generated passages, and this way you can fine tune it for this self-checking loop. As far as I remember, there are two very basic papers to improve. One is, I think this, let me search a bit, chain of thought reasoning, self-consistency and the chain of thought reasoning. And the other one is basically removing hallucination through self-check. Okay, so you may see this one. I'm putting this link in the chat. This is a way of, getting rid of this hallucination from GPT-3. So you can check it. And it's very difficult to tell you off-the-shelf solution immediately because, it depends on the way you reason or prompt, and it varies from context to context. But this paper is kind of, good starting point. Okay.
Thank you, sir. Thank you, sir. Sir, just one add-on to this question, sir. Also coming to the, sir, the expense of fine-tuning GPT-3, can I just, like, I do not want to use prompt engineering post the fine-tuning. Sir, can I use some other transformer model? I had tried with Hugging Face transformers like long format, but issue is the number of tokens.
They are very small. See,
Yes, sir.
Hugging Face, you can train them on your system, but they would be, the training set is not at all comparable to the breadth and expansion of GPT. So even if you have a control on the training set, but that doesn't guarantee that it will work very nicely for all unseen purposes. So Hugging Face, good for learning or good for training for pure academic purposes. But if you really wish to have a tangible outcome of translating a book, it is not.
Okay. Thank you, sir. Thank you for.
Hello. Hello, good afternoon, sir.
Yes.
Hello, sir. Sir, like I also was seeking for a suggestion. Actually, sir, I am starting off with LLM, and today's presentation was quite resourceful for me. So I'm starting with my research with respect to LLM, and being a beginner, I'm reading some research paper with respect to hallucination and how knowledge injection, knowledge graphs, all are working towards it. But sir, I wanted to understand, like being a beginner and wanting to work on a correct way towards research. You know, which way do you direct? Like which part do you think is better for me to start off, sir?
You have to first be acquainted with the basic transformer model, representation of text, both BART and GPT, and then you can go to the design of prompt for specific purposes. There are lots of use cases. Unfortunately, for the practical side, I cannot suggest you train your own foundation model. Best way is involved into prompt engineering, chain of thought, understand what is chain of thought, and then come up with latest ways of reducing hallucination and creation of multitasking ChatGPT for reasoning, interactivity with less hallucination, what is contrastive learning, how contrastive learning can reduce hallucination in different conversations. Also, another very interesting direction could be if you are proficient to some extent with computer vision, then this multimodal GPTs where less work is being done. So text to image, vision to text, and there you have some control because the imaging side will be with you. So different type of text to image translation tools and image to image translation tools. There can also be hallucinations in GPT-4 like systems.
Yes.
How such multi-modal data hallucination could be reduced. These are essentially the modern topics.
Yes, sir.
Yeah.
Oh, yes. Thank you, sir.
Okay, so I think thank you all for attention. I have to also leave. I have another meeting in half an hour. So if you have other questions, you can offline contact me through my email ID. Okay.
Thank you so very much, sir, for giving us the time, and we hope in future also we get the similar opportunity to interact with you and many more things. Thank you, sir.